Using the trigonometric identity for tan a plus b, prove that tan 3x is equal to that fraction there. So I'm going to rewrite tan 3 theta as being tan of 2, or have tan 3x as being tan 2x plus x. This is the same as that. I'm now going to use the tan addition formulae from the formula booklet. So this will give me tan 2x plus tan x divided by 1 minus tan 2x tan x. Now I can see that I want only tan x. I don't want to have this 2x here, so I need to use the tan double angle to expand these out. Now I know that tan 2x is equal to 2 tan x over 1 minus tan squared x. That's the tan double angle formula. So I'm going to substitute this in here and here. Now it's going to look a little bit messy to begin with because we're going to have a fraction within a fraction. But that's okay, we'll deal with that in a minute. Okay, so I've substituted it in. I've now got it only in terms of tan x. There's no tan 2x now. So that's good. But we've got this nested fraction, a fraction within a fraction. So I need to deal with that. I need to get rid of these fractions within this larger fraction. Well, the best way I can do that is if I multiply everything on the top here by 1 minus tan squared, because that would cancel this out and get rid of it. But obviously I can't just times the numerator by that, I would have to times the denominator as well. So let's work through that. So like I say, when I times that on the numerator, that will cancel this out and just leave a 2 tan x plus, now obviously this tan x here, that still needs to be multiplied by that 1 minus tan squared. So the tan x times 1 is tan x. The tan x times the tan squared is tan cubed x. Now on my denominator I've got the 1 at the front here, so that needs to be multiplied by the 1 minus tan squared. And then this will be cancelled with this to just leave this 2 tan x times tan x, so 2 tan squared. If I now collect up these like terms, I get 3 tan x minus tan cubed x over 1 minus 3 tan squared x, which was what we needed to show. So that's part A. Let's move to part B. Hence, solve between minus 30 and 30. Tan 3x equals 11 tan x. So it says hence, so obviously I'm going to take this and I'm going to replace it with what I just did. So 3 tan x minus tan cubed x over 1 minus 3 tan squared x is equal to 11 tan x. Multiply both sides to get rid of the denominator. So 11 tan x times 1 is 11 tan x. 11 tan x times 3 tan squared x is 33 tan cubed x. move everything onto one side of the equation. So I'm going to take away the 11 tan x from both sides, and I'm going to add 33 tan cubed to both sides. So minus tan cubed plus 33 tan cubed is 32 tan cubed x. And the 3 tan x, take away the 11 tan x, is minus 8 tan x equals 0. Just give myself a little bit more room because I'm now going to factorise. That's my next step. Because we have an 8 tan x in both of these terms. So I can now say that either 8 tan x equals 0 or 4 tan squared minus 1 equals 0. Oops. So firstly, if 8 tan x equals 0, that means that tan x equals 0. So tan inverse of 0 is 0. And I don't need to draw a graph. I know that's going to be the only answer between minus 30 and 30 for this. So that is one answer so far. Now we need to look at the 4 tan squared minus 1 equals 0. So that means that tan squared equals 1/4. Square rooting tells me that so the square root of a quarter is either a half or minus 1/2. If I now do tan inverse of a half, I get 26.6. If I do tan inverse of minus 1/2, I get minus 26.6. And those are, not sure if I can get that out now. Anyway, these are my three answers: 0, 26.6 and minus 26.6. Those are the three answers between minus 30 and positive 30.